Okay, this is geometry 1.3 still, part 4. Sorry about all the different parts, but there's kind of a lot of information in, and I didn't want to make each of the videos too long. So on the last part, we talked about figuring out the midpoint between 2 points in a coordinate plane. We could also figure out the distance between 2 points in a coordinate plane, or finding the distance between 2 points in a coordinate plane is also the same as figuring out the length of the segment, whose endpoints are 2 points in a coordinate plane. So we still have our 2 points in a coordinate plane. Call them x sub 1, y sub 1, and x sub 2, y sub 2. In this video, I'm just going to go through exactly what the distance formula is and how to use it. I'll make an extra video that's kind of going to be optional to watch to figure out exactly how the distance formula is derived. But the distance between these 2 points, x sub 1, y sub 1, x sub 2, y sub 2, is going to be d. So d represents a distance, just like if you use the equation or formula, d equals rt. D is the distance is equal to rate times time. But the distance is the square root of the difference of the y coordinate, so y sub 2 minus y sub 1, that quantity squared, plus the difference of the x coordinate squared, x sub 2 minus x sub 1 quantity squared. Even if you don't want to watch the other video on how the distance formula is derived, it actually comes from the Pythagorean theorem. All right, but to figure out the distance between 2 points. So on the example below, I want to calculate the distance between the two given points, A and B, and then that's also the same as being asked to figure out the length of the segment whose endpoints are at A and B. So similar to the midpoint formula, what's always going to be helpful is if you label your points x sub 1, y sub 1, and x sub 2, y sub 2. In case you're wondering, I could have labeled point B, x sub 1, y sub 1, and then point A, x sub 2, y sub 2. If you don't believe me, it's going to give you the same distance between those 2 points, regardless of how you label it. You could try it on your own if you want. But then the distance between those 2 points is also figuring out the length of the segment is d is equal to y sub 2 minus y sub 1. So negative 6 minus 1. That quantity squared plus x sub 2, 12, minus x sub 1. So it's 12 minus negative 9. Subtracting a negative is the same as adding the positive. So 12 plus 9, quantity squared. And then you have to use your order of operations. So do everything in parentheses first. Negative 6 minus 1 is negative 7. And then we'll square that. I'm just going to write everything out to show all my work. Plus 12 plus 9, 21. That's squared. You have to do everything underneath the radical or square root first. So negative 7 squared, 49, plus 21 squared, 441. And I still need to do everything underneath the radical in order to simplify. So the distance is 49 plus 441, the square root of 490. Right now, here's what I'm going to do. Just simplify. Sometimes the directions might say round your answer to the nearest tenth. I'm not going to go through right now simplifying the radical, putting the radical in simplest radical form, but I could just take, excuse me, on my calculator, the square root of 490, and then round it to whatever. Say I want to round it to the nearest tenth. I just always want to make sure I follow directions. Sometimes it might say something like round it to the nearest, I don't know, hundredth or something. So that's about, if I round it to the nearest tenth, on my calculator, it gives me about 22.13. That's all I really need to round it to the nearest tenth. The 3 is less than 5, so it stays 22.1. And in this case, just units, or u, since we're talking about a distance or a length. But that's a distance between those two endpoints of segment AB.